Okay, guys, today we're going to be multiplying our square roots. This is very similar to what we were doing last week when we were simplifying. So last week when we were simplifying, we were able to take what was underneath the radical and break them up into its pieces. And now the multiplying is saying is if we have two things that are underneath the radical, we can multiply them or join them together. So there's going to be a method that we can do that will always work, and then I'm going to tell you my shortcut to show you how to save a little time. If my shortcut confuses you, don't use it. Okay. So in this case, our first example, we have root 3 times root 6. Since they're both irrational values and they're both underneath the radical, they can be multiplied together. So just like 3 times 6 is 18, root 3 times root 6 is going to be root 18. Okay. After we've completed this, we're going to have the square root of 18 and we're going to see, is this simplified? Okay. But when we look at it and we know our perfect squares that are less than 18, we've got 4, 9, and 16, and that's it. And 18 is divisible by 9. So if we can break that up into square root 9 times square root 2, square root of 9 you can take, and the square root of 9 is going to give you 3. So 3 square root 2 is going to be the simplest radical form of root 3 times root 6. Now, one of the things that I tend to use as my guide for knowing what's going to end up here is I look at this and I see this is root 3 and this is root 6. They're both divisible by 3. So what we're going to have here is if I broke up this one, root 3 times root 2. Okay, I'm going to have 2 root 3s when we're done. Basically, when you have 3 times 3, you're going to get 9. So I know that perfect square is probably going to be 9 if I just multiplied two things that are divisible by 3. So that's kind of my shortcut for getting to the next step a little bit quicker. So if I'm taking a look at our first example down below, I apologize. Let me erase some of these. We've got square root 10, square root 20. Okay. When I'm looking at that, I can say square root 10 times square root 20. They're both underneath radicals. I can multiply them together, and you would get square root 200. And then I would say, okay, what perfect square factors are in the square root of 200? Well, here I'm saying this is divisible by 10, and that's divisible by 10, and 10 times 10 is going to give me 100. So square root 100 times square root 2 is how we're going to end up breaking this up. So I had a 3 and a 3 here, and of course 3 times 3 is going to give me 9. I had a 10 and a 10, and 10 times 10 is going to give me 100. So that's how I'm getting my perfect squares a little bit quicker. Okay. Now, when we multiply, when we simplify this, square root of 10 or a square root of 100 is going to give me 10. Square root 2 we can't take, so it stays underneath the radical, and that's going to be my simplified solution. Okay, now moving down to the others, the numbers are going to start to get a little bit bigger, and it's okay. I don't think we're going to do every single one of these examples. This last one, I think I'm going to wait till a later video. Now, if I'm looking at 3 times the square root of 2 times the square root of 72, in that, I'm going to see a 2 and a 2. So I know that we're going to be able to take out a 2 at one point. But if I divide this by 2, that's going to give me 36. So I'm going to end up with 2 perfect squares. So this is going to be totally rational when we're done. Okay. So rather than taking out the 2, I can see that 2 times 72, that is going to be 144. Okay. So I was kind of gearing up thinking there's going to be a 2 and a 2. So a perfect square root 4 will come out. But what was left was a 36, which is also a perfect square. Okay. So if I'm going to take the square root of 4, which is going to be 2, and the square root of 36, which is going to be 6, I'm going to take out a 12. Okay, so you can see 2 times 72, 144, and we all know the square root of 144 is 12. So once I take the square root symbol goes away. We now have a rational value. 3 was sitting on the outside. It's going to be multiplied by 12, and that's going to give me 36. So just for reference, let me keep the first solution up. 10 square root 2. Okay, now I'm looking here. I've got rational 3, irrational square root 6, rational 4, irrational square root of 8. I can already see that they're both even, so at least a 4 is going to come out, if not more. But let's take a look. 3 times 3, so rational times rational, that's going to give me, or that's going to be the coefficient. Underneath, I have the 6 times the 8. 6 times the 8, okay? So 3 times 6 is going to give me 12. 6 times 8 is going to give me square root of 48. Okay. Now, in the square root of 48, I said there was at least going to be a 4. I'm going to check beyond that. You can see that it's going to be also another 4. So the square root of 16 times the square root of 3. Square root of 16 times square root of 3 gives you the square root of 48. Square root of 16 is going to be 4. So I've got the 12 on the outside. Now I'm going to have a 4 joining that with the square root of 3. Now 12 times 4 is 48. So 48 square root 3 is going to be simplest radical form. Okay, here we're squaring this. We actually get a shortcut is we can actually square each individual portion here, or we can write it out. Okay, so I think to alleviate confusion, I'm going to write it out, and we'll do the shortcuts in a later video. Okay, now the 3 times 3 is going to give me the 9 on the outside, and the root 5 times root 5 is going to give me a root 25. Okay, now the square root of 25 we can take, and that's going to be 5. And 9 times 5 is going to give me 45. And there's your simplified answer. Okay, so we have a couple rational values when we're done simplifying, and a couple irrational in simplest form.